In today's class, we'll be doing load combination. We're going to do load combination according to American code. But before we continue, I want you to use 2 seconds to subscribe to my channel. If you have not done that before, please subscribe, like, and share. Okay. So we go to loading. You click on combination load case. Load. So okay, you can now go to my Excel sheet where I already have put down the factors and the combinations. So see, load combination in accordance with American Society of Civil Engineers 705. This is the code that I used for this load combination. So the code specifies the factors for dead load, live load, temperature load, wind load, snow load, if it's applicable in your own design. But in our own design here, we don't snow load is not applicable. Okay, so you're going to be having under load numbers. The way I normally number my loads, I start with 101, 102, 103 to the last one, 115. Okay, now if you look at this 101, we are going to be combining all the dead load with a factor 1. So because this load combination is allowable stress design load combination, which is the same thing as serviceability limit. So the second one is combination of all the dead load and live load. So let us quickly look at the code where those factors are specified. This is the American code, the American Society of Civil Engineers. Combining factored loads using strength design is the same thing as the ultimate limit. So when you are combining dead loads, use 1.4, dead load plus live load, use 1.2, 1.6 for live load, just like that. So the factors I used in my load combination are gotten from here. Combining nominal loads using allowable stress design. So this one is the same thing as serviceability limit. See, the factors are just 1, 1, 1. Then for this place you have 0.6. So let's go back to the Excel sheet and pick them one after the other. The first load combination is 101. We're going to combine DL1, DL2, DL3. In our previous class, we have already added all these primary loads and we gave them names as displayed there. Let me close here. From here you can see self weight is DL1, grating load is DL2, and weight of empty tank is DL3, just like that. So the first load combination, I'm going to call it allowable stress load combination. Allowable stress load combination 101. Copy. This one is just to combine all the dead load. Yes. You click on add. The factor is 1 already automatically, so I don't need to edit it. Click on add. You have made changes, yes, I know. The second one, 102. Check the Excel sheets again. Combination of dead load and live load, including temperature load, all with the factor 1. Yeah, all with the factor 1. Temperature load, factor 1. Click add. The third one, 102, is the dead loads. We have factor 1, while the live loads we have 0.75, including the temperature load. Quickly add that. All the dead load 1, the live load 0.75, including the temperature. So have 0.75, 0.75, 0.75, 0.75. Click on add. The fourth one, is dead load and one of the wind loads with factor 1. So the next one after that is we keep adding the other wind load, the other wind load and the other wind load, keeping all these dead loads constant. We want to know the behavior of the structure when wind is coming from each direction at different times. That's the idea. So we come here again, all the dead load factor 1, then wind load in X direction. Now click add. This one is 5. The reason why the live load is not added here is we want to know what will be the wind effect on the structure when it's not carrying anything. A structure that is being constructed, maybe they just finished construction and there is wind. So what will happen to the structure? Because when you load the structure, it helps to stabilize it. It has to work against wind. So the structure is more stable when it has a load on it. When it has the tank full of water, it is more stable like that. But when there is no tank and there is no water, the structure is lighter. So wind effects will actually affect it more. We show when it does not have anything is carrying. So that's the reason for eliminating the live loads and applying wind from each direction to see how the structure is going to react to whether it can resist it or not at serviceability limit. We also still do that during ultimate limit combination. So for this one, all the dead load, then the one of X minus X, we add the other one, 6, all the dead load plus Z direction, we add 7, all the dead load Z minus Z direction, we add. Yes, so we go again up to 7. We have done that. Then 108, all the dead load factor 1 live load 0.75. Then we are now bringing in the live load now and wind load. Okay, for have 0.8, the dead load or the live load 0.75, 0.75. Okay, then the wind load in X direction. And click add. $109. All the dead load, live load. Minus X direction. $110. The dead load, the live load. Z direction. $11. Minus Z direction. Click on add. Okay, that's 111. Okay, then the other one is we now reduce the self weight. Assume the self weight is lesser this time. Then we apply wind load 0.6. All the dead load 0.6. Wind load in X 1. $13. 0.6. 0.6 minus X direction. $13. 0.6. 0.6. 0.6. minus Z direction, $14, .6, 0.6, 0.6 minus Z. Okay, with this we are done with the allowable stress load combination. So let's quickly do the second one, the strength design load combination, which is the same thing as ultimate limit state. Limit state. This one is also limit state. Strength design load combination. Let me just copy. So this one is 201, starting from 201. So the first one is only the dead loads 1.4, just as stated here. When you are combining only the dead load, when you're combining only the dead load, you use 1.4 as the factor. So dead loads 1.4, 0.4, 0.4. Let me copy this, add 202, is dead load and life load with temperature load. This time around the dead load is 1.2, 1.2, 1.2.2. The life loads 1.6, 1.6. Then the temperature load 1.2. (203). Dead load 1.2, life load 1, and wind load 0.8. (1.2). Life load 1, wind load 0.8. (204). (1.2). 1 0.8 to 5 1.2 1.2 1.2 positive Z 0.206 0.8. Okay. Okay, stop at 206, 207, 1.21, 1.6, wind load 1.6, dead load 1.2, life load 1.2, life load 1, wind load 1.6. That's 207, and 208, 1.2, 1.6, 209, 1, 1.6, 210, 0.2, 1.6, and that's 210, 210. So the last set is 0.9. When the dead load is reduced, then life load and wind load increased. This particular load combination is to check overturning, how the structure is going to overturn when a heavy wind comes, and assuming the wind and the self weight is less than what it's supposed to be and is not carrying anything. So this is used for foundation stability, this particular load combination. Foundation stability, the overturning moment at the footing of the supports. Okay, dead load 0.9, wind load 1.6. Okay, 211, dead load 0.9, 0.9, 0.9, 0.9, no life load, wind load 1.6, and 212, 0.9, no life load, wind load 1.6, 213, 0.9, 0.9, 1.6, and the last one 214, 0.9, 0.9, the last one 1.6. Okay, that's the end of our load combination. Let me minimize all this. Yes, so these are my load combinations, the allowable stress load combination from 01 to 114 to 114. Then we have a strength design load combination from 201 to 214. Okay, let's run the analysis again. Run the analysis. We save. Yeah. Yes. Wow, that's good. We don't have any error. We don't have any warning. That's wonderful. So I think we'll end here. We'll end here for today. Next time we're going to be doing design proper. We have done analysis. We can do design. Do design proper. We can still go to can see some of our analysis results. Yes, analysis results. You can remove all these primary loads, remove them, so that the result that will be shown will be for the combination. Come to the reaction, and this table gives you a summary of the support reaction. Summary of support reaction. See horizontal load maximum, vertical as in y direction. We have 243 as maximum load, vertical point load. At FZ you have this MZ, maximum moment 8.7. Yes, that's that. Wow. Then static checks, everything is balanced. Everything is balanced. You can check beam results to see the bending moments. Summary of bending moments as a moment on the beams. As the bending moment diagram. Under results, from here can be selecting the loads, because this bending moment diagram that is being displayed here is according to any load you select here. So as you are selecting, the diagram keeps changing. Each load combination gives a different value for moments and shear. So what from this table you can see the maximum of it. If you go to summary, this one returns the maximum moment. Yeah, and that result. The MZ is active to show me MZ moment in Z direction. That's that. So after the design, in our next class we are going to be checking the utilization ratio, which shows whether a member passes or fails. So don't miss the next class. Okay, we'll stop here for today. We're going to continue next time. Remember to subscribe, like, and share with your friends. Thank you for your support so far.